Yes, we'll get started. Yeah. See, in the previous problem sheet, we have one more problem left, right? So before moving on to the next topic, let me just finish that question. Yes. Please take your problem sheet number 10. Please take your sheet number 10. Please take your problem sheet number 10. Yes. So we have one problem left, which is this one. The solution of the equation 1 by 6x plus 1 by x plus 2 is equal to 1 divided by 2x. So again, when you see the question, you have to immediately write what? Your x cannot be 0, x plus 2 cannot be 0, which means x cannot be 0 and x cannot be minus 2. You have to write it down because if x is equal to 0, there are two terms with x in the denominator. They will become undefined. If x is equal to minus 2, the term x plus 2 will be in the denominator and that will become undefined. So if x is equal to 0 or x is equal to minus 2, your original question is going to become undefined. So after solving, if you obtain any of these numbers as the solutions, you have to discard them. You cannot accept them as the solutions. That is the idea. Okay. So now let's move on to solving this question. So what do we have here? We have 1 by 6x plus 1 over x plus 2 is equal to, right? Now you might want to simplify this side right away. You might want to simplify this side right away, but it is easier. It is easier if you take this 1 by 6x to the other side. You will see why. You will see why. See, we have 1 by x plus 2 is equal to 1 over 2x minus 1 over 6x. Now this is simply, you can take 1 by x outside. So this becomes 1 by 2 minus 1 by 6. Understood what I did? I just took out the common factor. I just took out the common factor. Remember, 1 by a into 1 by b is 1 divided by ab. Cool. Now this is easy to do because 1 by 2 minus 1 by 6 can be simplified. This 1 by 2 minus 1 by 6 is going to be, this is going to be 3 divided by 6 minus 1 divided by 6, which will be 3 minus 1 divided by 6, which will be 2 divided by 6, which is 1 by 3. Which is 1 by 3. Yes. So 1 by x plus 2 is going to be 1 by x into 1 by 3. So this is 1 by 3x. 1 by x plus 2 is equal to 1 by 3x. Yes, so far so good. So I'll just explain once again. Instead of simplifying the LHS right away, I've taken 1 by 6x to the other side so that you have a 1 by x term outside and you don't have to deal with x when you're simplifying the fractions, because it's simply 1 by 2 minus 1 by 6, which comes out to be 1 by 3, right? And the LHS, you have 1 by x plus 2. Now you just cross multiply or simply take reciprocals on both sides. You just cross multiply or think of taking reciprocal on both sides. So we have x plus 2 is equal to 3x. Right? So we have 2 is equal to 3x minus x. So we have 2x and your x value comes out to be 1. X value comes out to be 1. And you may want to actually go back to the original question and substitute. You may want to actually go back to the original question and substitute and verify if it actually works. See, we got x is equal to 1. Okay, we got x is equal to 1. So if we go and substitute in this becomes 1 by 6 into 1 plus 1 by 1 plus 2 is equal to 1 by 2 into 1. 1 by 6 plus 1 by 3 is equal to 1 by 2. See whether this is true. This is 1 by 6 plus 2 by 6, which is 3 by 6. 3 by 6 comes out as 1 by 2. So it is correct. It is the correct answer. It is the correct answer. Yes. Of course, there is some correction in the solution given. There is some mistake in the solution given. Okay, I'll rectify and give you the updated problem sheets later on. Yes, so this is fine. Tell me this is fine. Yes or no? Yes. So that was the last problem from problem sheet number 10. Okay. Now, we have seen so many different kinds of uh, linear equations. So we know all the methods to solve linear equations, simple linear equation having variables on both sides, linear equations which have like terms which needs to be combined, linear equation which has brackets which needs to be expanded. Then there are equations which can be converted to linear equations. All sorts of linear equations we have seen. Now we are moving on to word problems. So instead of a mathematical statement, a statement in English will be given. So you have to actually convert it into a mathematical statement first and then solve it. Okay. So we'll start with easy problems. So this is problem sheet number 11. So idea is very simple. A linear equation can be often used to model a real world problem. So let's see first question. In the given triangle, what is the value of x? Can you just try? Take a minute or two, try and let me know the answer. In the given triangle, what is the value of x? I'm sorry, something went wrong. It's visible now. You can see the question now. Can you see the question now? Yes. Please have a look. Please have a look. Yes, what about others? You have the right answer. What about others? Yes, what is the idea? The sum of our angles of a triangle will be 180 degrees. So we have x plus 85 will be 180. So 2x plus 85 is going to be 180, and 2x is equal to 180 minus 85, which is going to be 95, and your x is going to be 47.5. Cool. That's a very easy question. Got it? Yes. Next question. The perimeter of a rectangle with sides x and 2x plus 10 is 32. What is the value of x? Uh-huh. You're doing problem number 2, right? How come you're getting 11? Anybody has a different answer? See, we are talking about perimeter of a rectangle. What is the perimeter of a rectangle? We are talking about the perimeter of a rectangle. See, for a rectangle, I hope we have already seen this. If this is its length, if this is its breadth, this is also L and this is also B. Yes, right. And perimeter will be the length, sum of length of all the sides, right? Perimeter will be the sum of length of all the sides. So you have L plus B plus L plus B, which is 2 times L plus B. You have seen this? Have you seen this? Have you seen this expression for the perimeter of a rectangle? Yes. But then you messed up, right? Because the side lengths are given to be x and 2x plus 10. Side lengths are given to be x and 2x plus 10. Side lengths are given to be x and 2x plus 10. So how do we do it? The length and breadths are given. Length and breadth are given to be x and 2x plus 10. And the perimeter is given to be 32. Right? Yes. Please rectify your steps. Please rectify your steps. Yes, cool. That's very good. We have 2 times x plus 2x plus 10 is equal to 32. So from that, we have, you can combine these terms. By the way, you can take 2 to the other side. So we have combined these two terms as well. We have 3x plus 10 is equal to 16. So we have 3x is equal to 6. X is equal to 2. X is equal to 2 is the right answer. Robin and Olivia, do you want further explanation? Robin, yes, got it. Cool. Yes. So let's see problem number 3 now. Let's see problem number 3. Read the question, understand the question. Okay. The statement is given in English. You have to convert it into a math statement and then solve it. What number should be added to twice the rational number minus 7 by 3 to get 3 by 7? What number should be added to twice the rational number minus 7 by 3 to get 3 by 7? Yes, cool. Yes. B is the answer. B. 107 over 21 is the answer. Others. What number should be added to twice the number minus 7 by 3 to get 3 by 7? So the idea is you have an unknown quantity. You call it x. Okay. So x should be added to twice the number minus 7 by 3 to get 3 by 7. That's the idea. So when you have a statement, when you have a word problem, you have to first understand what the unknown quantity is. You have to choose that unknown quantity and then represent it as a variable. Then convert the given statement into a mathematical equation and then solve and get the answer. That is the whole idea. I'm waiting for Anjali. I mean, Olivia, Prisha, and Robin has replied. Yes, that's cool. This is how you do it. So let's assume that the unknown number is x and x should be added to twice minus 7 by 3 to get 3 by 7. So x plus minus 14 by 3 is equal to 3 by 7. Now it's just a matter of simplification, right? So this is 3 by 7 plus 14 by 3. How do you simplify? Bring out the common denominator, 7 into 3. So this will be 3 into 3 plus 14 into 7. So that is 9 plus 14 into 7 is going to be 98 divided by 21. So that is 107 divided by 21. Cool. Yes, this is easy, right? I mean, it's pretty easy, right? Pretty easy, right? Word problems. Now let's see question number 4. No, let's move on to problem number 5. 4 you can use, do as a homework. Question number 5. We'll see question number 5 now. We'll see question number 5 now. Please read the question. Question number 5. Please read it carefully. Anybody has an answer yet? Yes. Oh, okay. Yes, yes. B is the answer. Now, you should be sure of the answer because, B is the answer. So, anybody has the answer yet? Yes. Okay. Listen. Please listen carefully. Listen carefully. This is a very typical SAT problem. Okay. The first instinct that may come to your mind when you see this question is panic because it's very lengthy. There are too much information is given in the question, including numbers. There is too much information given in the question, including numbers. So this is a trick to say distract you because these numbers 1850 and 1900 are useless numbers. Okay, they don't have any role in the problem. Okay, and there are two long sentences given in the question, but ultimately the essence of the problem, the crux of the problem is very simple, right? Because the number of states that joined United States between blah 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 is twice the number of states that joined between blah blah blah, right? 30 states joined US between these 2 years. X states joined between these 2 years. Then which of the following equation is true? Now look at the first statement again. The number of states that joined, so 30, is twice, is means equals, twice the number of states. So this number is given to be x. So it is 2 times x. As simple as that. Okay. Read the first statement, read the second statement. First statement says that some number is equal to 2 times some other number. In the second statement, the first number is given to be 30. The second number is given to be x. So we have 30 is equal to 2 times x. That's all. Is this fine? Is this okay? I mean, at first glance, this question might look lengthy, complicated, scary, but it's not. It's very simple. It's a typical, very, very, very typical SAT problem. Okay. Got it? Do you want further explanation? Please do let me know if you got it. If you got it, if you understood it, let me know it. Yes. Robin and Olivia, please do let me know if you have further confusion. If you have any confusion, do let me know. Yes, Robin. All right, all right. So this is a typical question. Okay, the typical SAT problem will look like that. Instead of giving a simple equation, they can give you a long statement, lengthy statement. You have to understand it. Okay, so we don't have too much time. We don't have too much time. You typically get 80 seconds to crack a problem on an average. We already know that. So the idea is read the question, understand what is the useful information, and there will be definitely useless numbers given in the question. So the numbers are they have deliberately given so many numbers to actually distract you. because there are too many numbers: 1776, 1849, 1850, 1900. These numbers are absolutely useless, right? Yeah, they just want you to check your comprehension as well as problem solving. Okay, then 6 and 7 you can try as homework problems. Let's go to question number 8. Let's go to question number 8 now. Problem number 8. A telecaller earns $150 a week plus $2 for each call that results in a sale conversion. It's not conversation, it's it's conversion. Sale conversion. Yes, that's cool. Yes, very good, very good, very good. Yes, that's cool, very good. Yes, it's very good. So let's quickly understand the question. See, there is one unknown quantity, which is the number of calls she converted into sales. So let's call this as X. Okay. And look at the payment structure for this telecaller. She has a fixed pay of $150, and then there's a variable pay. So her payment looks like this. She'll get $150 as a fixed amount, and for each call she converts, she'll get $2. So one call conversion, $2. Two call conversion, it's $4. Three call conversions, it's $6. So if she converted X calls, she'll get X into $2, right? As the variable pay. There is a fixed pay, and there is another variable component to her pay, which is dependent on the number of calls she could convert to an actual sale, right? So 150 plus X into 2 comes out to be 204. So 150 plus 2x is equal to 204. So we have 2x is equal to 204 minus 150, and this is 54. So your x comes out to be 27. Okay. Problem number 9, you can solve as a homework problem that I'll share the sheet with you. Yeah. Let's see question number 10. Who has the answer? Careful, 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 careful. Careful, 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 careful. Read the question thoroughly. In how many? In how many days? In how many days? In how many days will she have $500? So everyone yeah. Yes, cool, cool, cool. Olivia has the answer. Yeah. See, initially they are talking about earnings per week, right? So she is saving $20 per week. So initially, to begin with, she has $120, and every week she is getting $20. So suppose let the number of weeks is X. So in X weeks, she's getting X into $20. Getting as in she's saving up. Okay. In the end, this is amounting to $500. But here, X is the number of weeks. X is the number of weeks. X is the number of weeks. It's not the number of days. X is the number of weeks. So 120 plus 20x is equal to 500. So 20x is equal to 500 minus 120. That is going to be 380. So your x is going to be 380 divided by 20, which is 38 divided by 2 is 19. 19 is the number of weeks. Okay. At the end of which she'll have $500. How? She has $120 to begin with, and now every week she's saving up $20. So in 19 weeks, she'll have $380 saved up. With an initial saving of $120, it will amount to $500. But be careful. They have asked the number of days. So it's essentially 19 into 7, which is 133. 133 days is the answer. 133 days is the answer. So I have left some problems in between. Please do work them out for the next class. That is problem number 9. Then there is problem number 7. There's problem number 6. And there's problem number 4, which you can try out for the next class. I'll share the sheet with you in the WhatsApp group. Then let's move on to the next sheet, where you'll see slightly more difficult problems. Yes. So now we are going to see problems in which when you read the question, you might feel like there are two variables. It is okay to choose two variables and do the problem, but it's always better, easier, and faster if you do it using just one variable. Okay. You'll see the example soon. So the idea is simple. When you look at the question, it might look like there are two unknowns. Of course, there will be two unknowns, but it will be better if you choose only one variable and represent the other variable in terms of the first variable and proceed. Okay, we'll see the question. See this question. First question. Sum of two numbers is 74. One of the numbers is 10 more than the other. The larger number is. Sum of two numbers is 74. One of the numbers is 10 more than the other. The larger number is. Can you give it a try? Just give it a try and then I'll tell you how to do it. Please give it a try. The sum of two numbers is 74. One of the numbers is 10 more than the other. The larger number is. So the answer. Oh, that's very good. That's very good. Very good. See, what did I just say? There are two numbers. So you might want to choose them as x and y. X plus y is 74. One of the numbers is 10 more than the other. So let's say x is a bigger number. So x is no, okay, x is y plus 10. X is y plus 10. One of the numbers is 10 more than the. So this approach is using two variables. Okay, I'll tell you the approach using just one variable. Okay, listen carefully. Listen carefully. Please listen carefully. Sum of there are two unknowns. There are two unknown numbers. Sum of two numbers is 74. Let's choose them as x and y. So x plus y is 74. One of the numbers is 10 more than the other. So let's call x as the bigger number. So x is y plus 10. Now we have to solve this. So you have to replace x with y plus 10 here. Okay. So y plus 10 plus y is equal to 74. So we have 2y plus 10 is equal to 74. 2y is equal to 64. Y is equal to 32. So your x comes out to be 42. So larger number is 42. So this approach is using two variables. This approach is using two variables. But you can save your time. You can save your time if you just use one variable, right? How many of you did it using just one variable? How many of you did it using just one variable? Can you just say yes or no? Did you choose two variables or one variable? Can you please let me know? Okay. Okay. Cool. See, this can be done using just this. This approach is fine, right? You understood, right? Now, it's easier if you choose just one variable. Sum of two numbers is 74. And after that, read the next statement. One of the numbers is 10 more than the other. So one number, let's choose it as x. The other number can be chosen as x plus 10. If one number is x, the other number is x plus 10. Right? Now the sum of the numbers is 74. So sum of these numbers is 74. So you have 2x is equal to 54, x is equal to 32. And your other number is x plus 10, which is 42. So 42 is the larger number. So that is the second way to do it. That is the second way to do it. Now, of course, before actually going to work work out this problem, you have to also look at the options, because in this question, without actually doing the question, you can get the answer, because the answers are just staring at you. See this? See the options. See the options. If there are options given in the question, you always have a look at the options as well, because sometimes the options are sitting there, sitting right there, staring at you. Right? In this case, you see 32 and 42 immediately strike you that 32 plus 42 74, and they differ by 10, right? Sum is 74 and they differ by 10. You get what I'm saying? You get what I'm saying? You look at the options. The options are sitting right there staring at you. You have 32 and 42. So it immediately strikes you that the sum is 74 and the difference between them is 10. Cool? Yes or no? This will not work always, obviously. This will not always work, but it is always good to have a look at the options. You understood what I just mentioned? Give me yes or no. Hello, are you with me? Hello, 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 hello. Yes, okay, okay, good. Let's see the question number 2. The present age of, please work it out and take a minute or something. Take a minute or two and then get the answer. Question number 2. The present age of Ray's mother is 3 times the present age of Ray. After 5 years, their ages will be added to 66 years. Of course, there are two unknowns. There are two unknowns: Ray's age and Ray's mother's age. Okay. But you don't have to actually choose two variables and do it. You can just work out with one variable and solve the question. That will be quicker and easier. Yes, okay. So let's choose race present age as x. Then the present age of race mother is 3x. And after 5 years, their ages will be x plus 5 and 3x plus 5. And these will be added to what? 66. So you combine the like terms. We have 4x plus 10 is equal to 66. So we have 4x is equal to 56. Your x is going to be 14. X is going to be 14. X is going to be 14. Cool. Question number 3, you can try it as homework. I'll share the sheet with you. Yes, let's see question number 4 now. Yes, okay. Yes, good. See, the difference between two numbers is 66. The ratio of the two numbers is 2 is to 5. See, listen carefully. If the ratio of two numbers is 2 is to 5, it does not mean that the numbers are 2 and 5. Okay. The numbers can be 2 and 5. The numbers can be 4 and 10. The numbers can be, say, 6 and 15. Okay. You just need to have the ratio as 2 is to 5. You just need to have the ratio as 2 is to 5. So whenever such a question is given, always choose the numbers as 2x and 3x. Sorry, 2x and 5x. When the ratio is given as 2 is to 5, the numbers can be chosen as 2x and 5x. So always remember this trick. Always remember this trick. Always remember this trick because if you divide 2x and 5x, you're always going to get 2 by 5. If you divide 2x and 5x, you're always going to get 2 by 5. So whenever the ratio of two numbers is given as 2 is to 5, always choose them as 2x and 5x. Choose the numbers as 2x and 5x. Yes. Now the difference between the two numbers is 66. So the difference means bigger number minus smaller number. So 5x minus 2x is given as 66. So 3x is given as 66. So your x is given as 22. X is 22. X is 22. X is 22, right? So what did I do? There are two unknown numbers. Instead of choosing them as X and Y, I've chosen them as 2X and 5X, right? Now the difference between the numbers is given as 66. So bigger number minus smaller number is 5X minus 2X is 66. So if you solve it, we have 3X is equal to 66. We have X is equal to 22. Now we need to find the sum of the numbers. Sum of the numbers is going to be 5X plus 2X, which is 7X, which is 7 times 22, which will be 154. Cool. Let's do one more problem. Just quickly do one more problem. Let's do question number 5. And please complete this sheet for the next class. This sheet and the previous one. There are only a handful of problems. It won't take much of time. This won't take much time, okay? Please try it on your own. Question number 5. He would have needed, okay, needed. Noose bought a book and paid entirely using quarters. If he had instead paid using only dimes, he would have needed 9 more coins. How many cents did the book cost? Let's take 2 more minutes and then wind up the class, okay? Please try this question. Please try this question. Anybody has an answer yet? Yeah, $1.5. But remember, they have asked in cents, so it's 150. Okay, your answer is right, but you made a small mistake. right? Olivia, understood what I said? You gave the answer in dollars, right? Yeah. Okay. Yeah, it's $1.5, but it's 150 cents. Okay. Okay. Anyway, we have run out of time. We'll discuss this in the next class. I'll share these two sheets with you. Please do work out these questions because we've seen so many equations so far. Now we are actually solving real world problems. We are solving word problems which describes a real world scenario. Okay. So these kind of questions are very typical in an SAT. Okay. And these may look time consuming because you have to actually read up, understand the question, then frame an equation, then solve it. Okay. So the only way to crack it in a limited time is practice. So please do practice these questions. Okay. Okay, then see you in the next class. Wish you a very happy new year.